Here's a chip that we'll be working on. This would be an AND gate right there. Don't worry about the 74LS. Just be concerned about the last two digits, which is in this case 08. On the tower in class, you'll see that they're labeled with the last two digits, and that's how you find the chips. So notice that there's a notch there. So that's important to have your chip. When you put it in the board, it's got to have the same kind of notch. Notice that this says VCC. It actually means +5. And don't forget that there's the ground. So I'm going to show you how to connect it and make it work. Remember that multimedia is a great help to understand. That's what it's going to look like in multimedia. And you've got pin 1, pin 2, and pin 3. So multimedia, you only use one gate, but when you start doing it on your labs, you'll find that you'll be using all 4 gates. And by the way, a NOT gate has 6 of those, so look for that. Here's the physical chip that we saw as a schematic. And notice that there's a kind of like an indentation here. That's not the one you're looking for. You're looking for the one that has a notch on it like that. If you look very carefully, you'll see that there's numbers and letters here. And this one says, like I mentioned before, it's not really that important, but it says SN74. And it may say different ones. Manufacturers use different things, but the main thing that you got to look for is the last two digits, 08. I've written this over it to make it easier in the lab for us to be able to identify. If there's no writing on it, sometimes they make it black on black, which I find almost borderline cruel, but you have to look very, very carefully, and then you'll see 08, 00, 32, there's different ones, 86 I believe, and that's all you'll know. Always remember that when you have the notch has to be on the left, and what makes sense is the writing. You should be able to read it, and then you'll know that you've got the chip on properly. This is a close-up of the chip upside down. Make sure the legs are straight so they fit into the board properly. Let's try and put it into the board and see what happens. Here I'm just about to put it into the board. Make sure they line up with the, let's call them dots. They're little holes that where the legs go into. That's where you make your connections. Notice I put it in and everything is straight. None of the legs are bent. Let's look at an aerial view. None of the legs are bent. You got to be careful because you could bend the legs sometimes if they're not straight when you put it in. Now I'm going to insert the wire. So you have a red wire like this. Okay, so basically what you do is, depending on the wire stripper you have, you can just go like this, squeeze a little bit to get the lining, and basically you pop, and there you go. You have that. This is a pretty good length. You want to make sure it inserts into the board properly and doesn't leave any exposed wire. I see a lot of students that bring, first of all, the wrong color. Second of all, they have all this exposed wire. In one group, they did a very sophisticated demultiplexer. Nothing went right because everything was shorting out. They were making the wires too long. Don't do that. Make them just right, not too short, because then you don't get a contact. And I cut off a little bit more, and let's try and put it into the board. There's the VCC or +5 from the chip, and there it is. Let's try putting it in. See? Perfect. It's not exposed, but it's got a good contact. There's a side view. Notice that there's no exposed wire, which is really great. There won't be any shorts, no problems with this one. This is an aerial view, and if you noticed, like I said before, this wire now is connected here. Nothing else. It's not connected to that, and it's not connected to this side. It's only connected here. Remember that wire? I cut it I made it short. Notice there's no exposed wire. If I follow the line, it goes to the pin. And if I go here, this one would be the ground. So I went ahead and cut a black wire, and I did connect it to the negative railing. So now I'm ready to power up my chip. Alright, so now what I've got is a connection to that pin. So notice I put it on that railing. I call it a railing. Notice it's on the plus one. Let's look at the bottom one now. There's a chip. On the bottom right, you've got this pin. And where do I have it connected? Into the blue, which is negative. Now if we connect 5 volts here and ground here, it will activate this chip. Here's what it looks like a little bit higher. Really nice and neat. In the class, you'll notice we have these experimenter boxes. They can supply the 5 volts you need to power up your chip. Notice that this says 5 volts. If I come over here, notice that this says ground. And I've also put a black wire, because that's what we use for ground, black. And I put a red wire for +5. Remember the chip that we had? Well, there you go. Now the wire is connected in the red railing, and then that's how your chip is provided +5. And of course, the ground wire is connected to the black wire of the experimenter box using the blue railing. Here I have the first switch with the yellow wire connected to pin 1. Now a second switch connected to pin 2. This shows the wires that are connected to pin 1 and 2, the yellow wires. In pin 3, there's a resistor connected to an LED. This shows 2 1K ohm resistors connected to pin 1 and 2 of the chip, along with the yellow wires. These are the resistors that are connected. Notice it's a brown, black, and red. So it's 1 and 0 times 100, which makes them 1K, 1000 ohms. This is the 1000 ohm resistor, which is connected to pin 3 of the chip. It's also connected to the LED. This is the LED I'm going to put into the board. Remember, this is the short leg that goes into the blue railing for ground. This is the positive leg, which is positive, meaning it goes into the red one. I will show you now in the board. There it is. There's the ground leg, which is connected to the blue railing, and this one is connected to the resistor. Remember what I said, that this column, I call it a column for now, it connects the resistor to the LED. Nothing is connected there. Let's test it. 0 times 0 is 0. 0 times 1, the light still doesn't go on, still 0. 1 times 0, light still doesn't go on, it's 0. If I push both down, the light goes on. 1 times 1 is 1. Therefore, we have an AND gate.